Hi guys, I'm Nigel from ETS Fab, and thanks for joining us for today's free lesson. First, I'm going to give you a quick introduction so you'll know what to expect, and while I'm doing that, make sure you jump into the chat and introduce yourself. Let us know where in the world you're joining us from and what sort of projects you're personally interested in. This lesson is going to run for around 45 minutes today, and we're going to talk about some of the key concepts around motorsport fabrication. We'll look into tube bending with a live demonstration, as well as tube notching, TIG versus MIG welding, materials that we commonly work with in motorsport, and finally, a look at the top 5 tools I think every fabricator should have in their garage or workshop. Now, we're obviously not going to be able to cover every aspect of fabrication in motorsport in today's lesson, but you'll definitely be able to walk away from this with a few extra tips and tricks that you can use with your own projects at home. After that, we're going to have a question and answer session, which will be a good time for you to discuss anything that I've covered today, or even anything just generally related to motorsport fabrication. Now, just a note for mobile users, you're going to have a better experience if you have the opportunity to switch to a desktop, because we're going to be looking at a lot of detailed shots, and the bigger the screen, the more detail you're going to be able to get. It also makes it easier to interact with the chat, and that's how you're going to be able to get the most out of today's lesson. If you are watching on our website right now, in the chat we've got Jono, whose name shows up in gold. Jono is helping us with the technical side of today's webinar, so if you're having issues, then let him know. Right, let's have a look at who's on board for the lesson so far. So we've got a few people coming in, and it's good to see. I'll just give people a little minute. A few rolling in now from all around the world. Okay, so it looks like we've got a fairly wide spread of people joining us for the webinar, and thanks everyone for taking the time out of your day. For this, I think you'll be able to take something away from the lesson today. So before we rip into it, I'd just point out this little Facebook sharing icon, so feel free to take a moment and click on it to let your friends know that you're watching this webinar live today. They might want to join and learn a little bit more about motorsport fabrication. The more people we've got online at the end of the webinar, the more questions we're going to get and the more answers I'm going to be able to provide. All right, so with that very quick introduction out of the way, we're going to jump straight in and have a look at our first demonstration, which will focus on tube bending. So today I'm going to be using what's called an upright tube bender. There are a few different styles of motorsport tube benders on the market, but essentially they do the exact same thing. The horizontal bender sweeps the tube horizontally, while this upright bender allows us to bend the tube vertically. Now, I prefer this style because it's portable and doesn't need to be mounted to the ground, as its acting force is all confined within the frame of the bender. We spoke in length about this in the Motorsport Fabrication Fundamentals course and gave you the downloads to make your very own. I built this bender to create the tube chassis for my Hilux, which we'll talk about very soon. So let me just give you a demonstration on this machine, and like I said, this is an upright tube bender. Now, in the die here, we have what looks like this. This is, if you can see from overhead, this is a die, and it's machined round to accept each different diameter of tube. These are probably the most expensive part, well not probably, they are the most expensive part of any tube bending setup, and each die only suits each style of diameter of tube, and will set you back around 150 US to 300 US depending on the size. So that is the die, and then we have the follower. So the follower is typically made out of aluminium, and this is what the tube sits in while it's being pulled around the die, which we'll perform now. So on my tube here, which is 1.5 inch outside diameter, we have 2 different styles of angle meter. So what we need to do is take up the slack in our hydraulic ram, and this over center that is designed into the die will pull the tube up and create a bend that is specific for motorsport applications. So I'll take up the pressure and we'll zero out our bevel box, or you can see on this one here, and we'll just start bringing this up. So as I'm putting pressure on the tube bender, it's dragging the tube through the die, and because the die is specifically machined to suit this tube, it's not crushing it like you would with a normal pipe bender. And that's a good point. Pipe is actually measured on its inside diameter, whereas tube is measured on its outside diameter. So here we've got a bend of around 20 degrees, and we can go right up to 90 degrees on this style of bender, which is typical for any motorsport application. So I'll take off my angle meters, release the pressure. As you can see, the die returns back to its home position. We can take out the follower pin, then give the tube a sharp hit. And as you can see there, this is our 20-degree bend, and that's just one of the hundreds of bends that I've completed for motorsport use. So we'll put this back over on the bench. It really is a great way of bending tube, and once you have the tools to do it yourself, like this tube bender that we offered you the plans in the Fabrication Fundamentals course, then you'll find many applications to use it on. So that's the tube bending demo complete, and we'll also be having a look at tube notching and welding in a few minutes' time. First though, I'd like to give you a proper introduction to who we are and what we're about. My name's Nigel Petrie, and I'm the guy behind ETS Fab, which is really just a quick way of saying Engineered to Slide Motorsport Fabrication School. I'm streaming to you live today from Geelong near Melbourne, Australia. And here we specialise in teaching people how to fabricate within the motorsport world, which means everything from roll cages to MIG welding, TIG welding, and a whole lot more. ETS Fab has members from all around the world, and all of our courses are delivered via high-definition video modules that you can watch at any time. As many times as you like, provided you've got the internet connection. This means that you can learn from the comfort of your own home or workshop, and at a pace that suits you. At the end of today's webinar, I'm going to talk a little bit more in detail about exactly how ETS Fab works, and if you enjoy this lesson and maybe it whets your appetite, then you're also going to be presented with a special webinar only package deal that you can take advantage of. This is just to say thanks for coming along and watching the webinar live. Now, before I founded ETS Fab, I built up my own Engineered to Slide brand, which focused on custom car and bike builds, some of which, like my tube frame Toyota Hilux, you might have seen floating around online. I originally started out in the drift scene building S-chassis Nissans before going to work for Ford Australia. In the early days, there was no way that I could afford to pay someone to do all the fabrication on my cars, so I had to learn to do it myself. That need to save money ended up translating into a lifelong passion for me. And over the years, I've built up the skills necessary to create and hopefully inspire with what I'm putting together in my workshop. These days, I'm no longer working with Ford. I'm now fully committed to sharing what I've learned over my career with ETS Fab members. So let's take a closer look at some of my car and bike builds, starting with my favourite, the Drift Hilux. I'll just load up a few pictures of this just to take you through the process that was building it. So I started with a cab that I basically cut the floor out of because I really only needed to keep the outer cab to hold the doors. It was then a point of working out the wheelbase, building a tube chassis from the tube bender you saw that I demonstrated earlier, putting all the panels on and creating all of the tube structure and sheet metal structure inside the vehicle. This was all TIG welded. It was all tacked together with the MIG, and then I taught myself to TIG weld to produce the chassis. So that's my Toyota Hilux, which you'll see another photo of. All the suspension is made from chromoly, which is a higher carbon steel than mild steel, so it's a little stronger. And overall, the whole chassis and car weighs about 900 kilos. And it's powered by SR20 producing 500 horsepower. Now, as much as I love my Hilux, I also love my two-tone S13, which you may have also seen floating around. So this build was something that came after the Hilux, and it was built with using a mild steel roll cage. The engine bay was also completely, this isn't loading up, sorry, there we go. So the interior is all mild steel. This was so that I didn't have to get analysis done on the chassis side of things. You'll see the headers that sit behind me here. These are all made out of 316 stainless. And then there's a few other features in the car. But this was just a fun project that was built up to use a naturally aspirated SR20 and teach myself a few things about naturally aspirated engines and producing a pretty simple car. Obviously with a lot of fabrication involved. So here we have another build, and this is on the two-wheel side of things. This is a BMW R9T. So as you can see, I started with just a motor and then went through the process of building a jig for the chassis and then working out some dimensions and drawings to then build a complete chromoly front end and frame. We don't have to worry about that video. So this is the completed frame for the bike, and it all bolts on and off the factory R9T motor. So this was built for a show in America, and it was a really fun project that involved a lot of TIG welding. We don't have the fastest internet here in Australia, but we'll see what we can deal with. All of this was TIG welded using ER70 S6 filler wire, keeping the heat nice and cool, and a messy bench to boot. So another standout feature on this bike was the wheels, which I built from scratch. So these are all individual handmade spokes. Again, the internet is not playing ball with us. I'll go back to that original picture. So all the spokes are individual stainless steel items, all TIG welded together. So these wheels, along with the whole bike, all TIG welded, and it was a really fun process. And unfortunately, the event got cancelled in America, but overall, the bike is almost finished and will hopefully make it there next year. So that's not the only motorcycle I've built. There was another BMW before that, and you may have remembered this one with a TE37 rear wheel, along with my land speed KTM, which I set a land speed record on that uses a chromoly frame, and another KTM, which is one of the ones from the start that I sort of fell in love with motorcycles on. So along with the workshop and all of that. So to someone new to fabrication, a lot of the work you've just seen might seem a little out of reach, but the reality is that it's all done through skills that you can learn. Now, this stuff isn't quantum physics or heart surgery. It's real-world practical skills that with the right guidance simply takes a little time and patience to master. The reality is that learning to fabricate safe, reliable and functional pieces is well within the scope of most home enthusiasts, provided that you've got a reasonable eye for detail and a little bit of that all-important patience. That guidance is where ETS Motorsport Fabrication School comes in, something we'll talk a little bit more about at the end of this lesson. Okay, it's time to jump into the lesson, and the first thing we're going to look at today is tube notching. Now, you're most often going to be using this skill when building any tube structure, like you saw my Hilux chassis or the BMW chassis, or just a roll cage, as you saw in the S13. And while the idea is simple enough, mastering it is not that easy. We're going to cover materials, tools, planning out your notches, proper technique, and the commonly made mistakes that you need to avoid. So let's get into this lesson. So what I've got pre-set up here on the bench is my tube notcher. Now I've bolted it down, so I don't know how well you can see that, but it won't take a minute to show you this setup. So this is a tube notching tool, and it allows us to create a notch to a known angle. So it uses a hole saw. I'll bring this over here. So it uses a hole saw that is like so. This is a a very aggressive serrated hole saw. The one I've got in this machine is a lot more fine. And we connect up our drill onto the hole saw arbor, which operates this hole saw on an angle that is predetermined, so we can adjust our clamp that has our tube in it and then run our notcher through. So one thing to note when we're cutting any steel is that we need to cool the steel from the abrasion that it has. So what I'm using here is this Lennox lube tube, and I like to use this because it's a wax and it's not like a coolant, so it doesn't spray everywhere and contaminate the weld joint. This wax is really good because it stays solid until it heats up, and then when it does heat up, it coats the cut joint and cools and lubricates and makes the blades last a lot longer. All right, so now I've got my drill in here. I've already put my lube on the blades. So I'll run this through. Sorry about the noise, but that's cut through now. I'll back this out and show you the finished product. So using a drill to notch the tube creates a little bit of a jagged mess to start with, but you can use a file to clean this up. So I've cut this on a 30-degree angle, and as you can see, it would fit up to our tube like so after we give it a little bit of a file. So I've got a half moon file here, or a half round file, and it's a really handy tool to then clean up what your hole saw doesn't clean up, and to finish off the notch. So that's one way of performing a notch, and there's many different tools on the market that can perform a notch. This one is quite a simple one, and we did provide the plans for this in Fabrication Fundamentals course as well. So both of these items you can build yourself and save a considerable amount of money by using our courses. The next one I want to show you is the paper template method. So what you can do, there's a generator online or a calculator, and you just have to put in your parent tube, which is the tube that you're notching, your cut tube, the parent tube is the one that you're fitting up against, your cut tube diameter, the wall thickness, and the angle that you want to notch. So once you do that, you print this out, making sure that it's 100% aspect ratio, and then slip it over your tube. And as you can see, this is one that I've done earlier. Mark out your paper template and notch out your tube. So this will fit absolutely perfectly, creating no gap and a perfect weld seam. So this is something that's pretty common in motorcycle construction, roll cage construction, working with mild steel, chromoly, and many other chassis construction methods. So I'll just grab the drill out of here. Where's the pin gone? We'll slip that back in there, take the drill out into its resting position, and we'll chat about the final type of notch. And this will just be, and is quite common in motorsports, you won't be able to measure the notch or the angle that you're looking to fit up against, or it might be in a corner, like so. Then you would just get a Sharpie and mark out the steel like so, and then using an angle grinder, cut both sides away until you get the notch perfect. So notching tube is something that is really prevalent in motorsports. It's used for two wheels as well in motorcycles, and just something that is a good skill to have and a good tool to have in the fabrication workplace. So I'll pack up my bench a little bit here. So that concludes our look at tube notching. Next, I think this is a good time to discuss the classic TIG versus MIG welding argument. So both welding systems absolutely have their place in motorsport, but it's important to properly understand the differences and what works best for different types of jobs. Welding is a big component of motorsport fabrication, and it refers to joining similar metals together by creating an arc that melts the base material, followed by the addition of a matching filler material to create a weld seam. This weld seam joins the two parts into one, and this can be seen in every aspect of motorsports. There are two very popular methods of welding that we can do in our home workshops, and that is MIG or TIG welding. And today we are going to have a brief look at both methods and find out which method is going to suit your project. So I've got both welders set up here on the bench, and I've got this pre-notched and bent setup here that I'm going to TIG weld one side and MIG weld the other. So I'll switch on the machine, which should be switched on, put on my PPE. We prefer to use an automatic switching helmet, which means that when you put the shield down and create an arc, the arc will sense on your helmet and it will shade to a preset level. A really good tool because you can obviously see what you're doing. So we want a nice thick pair of gloves as well to make sure that we're not exposing any of our skin to the UV rays. And then we've got our TIG welder that will run first. So TIG welding is a very clean method of welding. It's very quiet. It doesn't have a whole lot of spatter. You can weld a lot of different materials with this method. It uses argon gas, and machines generally run around $1,000 to $2,000 for something that is able to weld aluminium and mild steel, and that's called an AC/DC welder. So this is a 200 amp AC/DC welder that I've got set up on DC for steel. So this is a mild steel join that I'm about to weld. And I've got a matching filler wire. So the difference with TIG welding is that you're inputting the filler wire by hand instead of with the MIG welder, which is by a spool of continuous filler. So what I'll do is I'll go ahead and weld this, and you'll see on this torch it doesn't have a switch. Down here by my foot I've got a foot pedal. So what that allows me to do is adjust the amperage mid-weld and really dial in the amount of weld amps that I'm using, both at the start, mid and finish of my weld, allowing me to back out if it's too hot, which is quite common when you're heat soaking something and the heat runs through it. So what we'll do is we'll set this up. Get down nice and close, and you'll see that I've got my tungsten stuck out a fair way to get into the join of this tube. Put my shield down and then start welding. Using argon gas, I've got my pedal about halfway, and I'm inputting that filler rod into the weld seam. And it's common to stop halfway along, spin the job around so that you're comfortable, and you'll notice that I've got this tacked in 4 positions to make sure that when the weld starts to cool down it doesn't pull the tube to the other side. And now I'll weld the other half. Another great thing with TIG welding is this cup that you see here directs the argon gas out of that, and that shields the arc on our weld. Now this can be adjusted for more gas flow via our regulator, but you can also use larger cups to produce a larger shield of gas, and that's really good for using the TIG welding method on higher reactive metals such as stainless steel and titanium. So that's our TIG welder, one of my favourite methods of welding. And now we'll switch over to the MIG, which due to the spatter that comes off it, I'll just put my rough Ernest apron over there to make sure that we don't damage the laptop. Alright, so now I've got my MIG welder, which I'll probably have to turn on. A MIG welder also uses gas to shield the arc, which comes out of this nozzle. Sorry, I'm having a bit of a mental blank. Which comes out of this nozzle, and this nozzle shields the contact tip, which matches the size of the wire, and this energizes the wire as it comes out. So what we need to do, we put the contact tip or the nozzle back over, and I've got this MIG welder set up on synergic mode, which means that it's quite a new machine, and synergic mode allows you to input the type of gas that you're running. On this, I'm running a mixture. The wire diameter, which in this case is 0.8 millimeter, and the type of steel, which is ferrous for mild steel. So I've also inputted the material thickness, which is around 1.6 mil here. So this will have a predetermined amount of amperage that should be pretty right for this application. So we'll just get in and give it a weld. As you can hear from all of that crackling and see all the sparks coming off there, it's fast, it's an aggressive type of weld, it's great for larger projects, and it's also really good for a lot of more intricate things once you have your machine dialed in, but you really can't beat TIG welding for smaller items. So I'll just weld the next section. And that is completed. So as you can see, again, MIG welding is much faster than TIG welding. Which is a stronger method? They're both equally as strong. Which is a cleaner and neater method? Definitely TIG welding. Which one do I prefer? Definitely TIG welding. But in saying that, I started out MIG welding, and you learn a lot from this process, and you can do a lot of projects, especially in motorsport, with your MIG welder. So I'll take my gloves off now, making sure not to touch that because it is extremely hot. Put my PPE away. Unplug the welder so the fan's not running. And there are many different materials, so that's our welding process all done. MIG and TIG both have their places in motorsport, but the TIG is a lot better, in my opinion, because you have the option to weld aluminium, titanium, and it's a much cleaner option. So there are many different materials used in motorsport, and this is a good time to check out exactly what material should be used for what type of job and how they work with each other. They all require their own special considerations, so let's take a closer look at them. First up, we have mild steel. So I've got some samples here. This is the same material as what I just welded. And mild steel refers to any steel with a low carbon content between 0.05% to 0.25% and makes up for most of the steels that we encounter at our local industrial steel shop. Mild steel is a great material to work with, as its low carbon content means that it won't be adversely affected by heat during welding, which opens up the opportunity to MIG or TIG your mild steel. It's easy stuff to work with, it's relatively cheap, and it won't require certification for roll cage or chassis structures. And overwhelmingly, mild steel will be the largest contributing factor to motorsport fabrication. I'll bring them all out on the bench. All right, next up we have stainless. So stainless steel is a great material for any exhausts, such as this V-band clamp, or any fluid plumbing that requires corrosion resistance. Although stainless can be MIG welded, it lends itself to the TIG welding method, as it can control the heat and reduce the size of the weld. And even back purge, stainless is really good to back purge to complete a full seal on the weld joint. Stainless steel does require some extra preparation methods that we go into depth in our Motorsport Fabrication Fundamentals course. So next up, we have aluminium. Now, aluminium is often seen in engine bays, and it's really popular for intercoolers, radiators, plumbing, and intake manifolds. It suits these areas because of its thermal conductivity properties. Aluminium will heat up and cool down nearly 4 times faster than steel and is extremely lightweight. And whenever we hear the term billet, it refers to the item being machined from a solid block of billet aluminium, which poses a much more controlled grain structure. Aluminium lends itself to TIG welding, and all fabricators will strive for that perfect stacked dime appearance, due to the fluidity in the weld pool and the actions of the filler rod inclusion. Our final material, and one that needs no introduction in motorsports, is titanium. Titanium is often used in high-end motorsports due to its extreme lightweight and high strength. It's available in thin wall tube for exhausts, bar stock for bolts and fasteners, sheet metal for bracketry, but one thing to note about titanium is that it must be TIG welded, and we must pay special attention to the shielding gas used, as it's extremely reactive at high temperatures and needs to be flooded with an inert gas. This means large TIG cups, like I showed you before, and back purging are essential on titanium, so the cost of manufacturing these items rises with the extra expense. So to finish up today's lesson, let's talk tools. We'll put these materials away. So there are a lot of tools on the market that everybody's trying to sell you, but there are really, you can get away with a lot. You can get away with a lot less in motorsport than you might first think. So first up, we have the measuring and marking process. So I'll lay these out on the bench. We have a series of rulers which will allow you to measure your material. We have a square that will make sure that whatever you're welding or setting up is square to the table or however you need. If it's not square, then we can use an angle gauge. This one's a digital one. We have a bevel box, which is a little bit different. And then we just have our markers, and these are really good for a Sharpie, obviously, for marking out your lengths of material. And then for getting down into the tighter stuff, we need a fine tip pen. So there's a huge industry out there, and like I said, everyone's trying to sell you the latest and greatest from their catalogue, but not all of it is essential or even particularly useful. So let's take a look at some other tools that I consider are the must-haves just to get you started in fabrication. So measuring is one thing, and grinding is another. So when we speak about grinders, we speak about angle grinders mostly, and an angle grinder looks like so. This is a battery-powered angle grinder. They're available in mains power and also air-powered. But what I want to speak about today is the types of buffing and grinding wheels that are available, and also the cutting wheels. So usually when you purchase a grinder, it might come with a couple of cutting, or what they call cutting and grinding discs. As you can see, this is a grinding disc, and it's extremely thick and rigid and will produce a really rough grind, and something that isn't particularly useful for motorsport. The cutting disc here measures a little bit over 3 mil and will create a lot of abrasion and heat in our materials, which we're not looking to do in motorsports. So instead, I like to use these 1 millimeter thick cutting wheels, and this is a 115 millimeter version to suit this grinder, and it's just 1 millimeter thick, and although they do wear quicker, they create a really neat cut, and it creates a lot less abrasion, which means that you keep the heat down, and that's important for items like chromoly, which have a higher carbon content and can work harden due to the heat. So when it comes to buffing your cuts, or buffing paint off, or any other aspects of motorsport fabrication and preparation, we have a few different styles of buffing wheels. So this is an abrasive disc. This is a single layer, and it's used with a plastic backing. These wear out quite fast, but they are quite useful and they're very cheap. So something that'll last a lot longer but also cost you a little bit more are these grinding discs that have separate sections that as they wear down they break off and create new cutting ridges. So this is a really handy one. It's got a radiused edge, which is great for getting into our tube notches. So when we're notching tube, we can use this grinder to get in, out and around our tube notch. And then the last one is the paint buffing or smooth finish flap disc. And this is really good for preparing your material without taking any of the actual material off it. So this is a grinder and something that will be extremely useful in motorsport fabrication, and whether you choose air-powered, battery-powered or mains-powered, just make sure that it's one that there are a lot of discs available for, and 125 or 115 millimeter would be, I guess, the go for motorsports. So next up we have a drill, and my mic pack's just ejected itself. Let me put that back on. Back. The dangers of live production, hey? All right, I think we're good. So, as I was mentioning before my mic pack exploded off the back of me, a drill. So you may need, this may need no introduction, but this is a cordless drill, battery powered. Again, this is a 54 volt battery pack, and these things have come a long way. I can go for days without having to recharge. And this here is a 3-speed drill. So we have speed 1, 2, and 3. And in speed 1, we rotate a little under 800 RPM, which is great for the larger drills and the hole saws that we operate. Speed 2 would be a mid-sized drill, something around the 10 millimeter. And then for speed 3, we use this for the smaller drills that we may be using. So that's a really good rule to kind of keep in mind. The larger the drill, the slower you go. The smaller the drill, the faster you go. So having extra speeds available on your drill is a really handy addition. This is a hammer drill, so really good for masonry work, which we do not do in motorsports, but if you're going to buy a drill, then you might as well have it work for home as well. So let's have a look at some of the bits that you use for drilling. So we've got some drills here, and like I mentioned, we want to run really slow with our hole saws. This is a bimetal hole saw with a really rough serrated tooth profile. Great for drilling large holes. This is a step drill, and as its name suggests, it steps up in size. One thing to watch with these, make sure that you use lube when using them, because you don't want to blunt any of these ridges as you run up, because it will pretty much render this useless, and they are quite expensive, so it pays to run some lube on them and to keep them living for a long time. The next up, we have just a normal twist drill. These are available in carbide or titanium nitride. So a good drill or a good set of drills will come in really handy. And again, make sure you use lube, and make sure that your speeds on your drill for a larger drill are slower, and they'll last a long time. So we do go through the process of sharpening drills in Fabrication Fundamentals course, and that will save you a lot of money, having the ability to sharpen your own tools. This one here is a center drill, and Really handy for pinpointing tricky holes that you want to open up. Really handy for, I guess, drilling on tube where something's trying to wander. With this one, you can start the drill and then open it up to 8mm, which is the size of this one. So drills are an important part of motorsport fabrication, whether you're hole sawing using a step drill or a twist drill. They're also available in the pedestal type, which is mounted to the floor. They're really good for things like notching tube and setting up larger size drills in, because obviously your wrists can only hold so much with a cordless drill. And also straightening, being able to drill straight holes through thick materials is really good with a pedestal drill, because it's perfectly set up on a 90-degree table. So that's drilling, and that's something that's obviously you're going to do a whole bunch of in motorsport, and a really handy addition. And we ran through the welders before. That's another really important aspect of motorsport fabrication. All right, so that pretty much covers our tools. Let me clean off the bench a little and we'll continue on. So with the above tools, you'll be able to get in and give projects a go without having to head to the shops that often. No one knows exactly what they need right away, but this will provide you with a great start into the world of fabrication. All right, so that brings us to the end of the lesson segment of the webinar, and I hope you've learned something useful. We're now going to open up the chat to any questions that you might have. So if there's anything from today's lesson that you want me to dive a little deeper into, then this is the perfect time to ask. The team is going to queue some questions up for me, so while we wait for those to roll in, let's talk ETS Fab and how it works. If you've got through today's lesson to this point and you've liked what you've seen, then we have a special webinar-only ETS Fab package deal that we're going to offer to say thanks for coming along and watching today. Just before we get into that, I want to fill in those who have joined us a little bit late. ETS Motorsport Fabrication School is an online training school. All of our courses are delivered via high-definition video modules, which means that you don't have to travel to us in order to learn. You can do it from the comfort of your own lounge, shed or garage, and you can learn at your own pace. Basically, you can take our courses from anywhere in the world, provided you've got an internet connection. All of our courses are also yours for life once you buy them. There's no expiry date, and you can watch them as many times as you like. This is really important to us because particularly when you're learning a new skill, there's always going to be a lot to take in, and chances are that the first time you watch one of our courses, there may still be topics that you don't quite get your head around fully the first time. This allows you to go back and review those particular modules that you feel that you need to understand better, and until you've got a full comprehension of every topic that's taught. This is also super helpful when it comes to our practical examples, because you can go back and watch the individual steps related to the process as you're doing them in real time on your own project, making sure that you're doing everything absolutely correctly. One thing that I really want to make clear with you guys is that you don't have to be an experienced fabricator to use our courses. Our Motorsport Fabrication Fundamentals course, for example, is designed as a first dip of the toes into the world of fabrication, and all of our courses, while very comprehensive in what they cover, always make allowances for those who are fresh to the fabrication and welding game. So you don't need to be a mechanic, you don't need to be a pro welder, you don't even need to have ever picked up a welding mask or a grinder before. We'll take you from zero previous knowledge to a point where you're confident and comfortable with all types of motorsport fabrication work. Roll cages, intercooler piping, manifolds, and everything in between. Now, it's important to note that our courses aren't a replacement for hands-on learning alone, and you're still going to have to get your hands dirty. The courses are going to set you up with the right knowledge and habits from the very start, which is going to ensure you don't waste time and money trying to learn using trial and error. So let's get stuck in and we'll look at what we have available. I already mentioned the Fabrication Fundamentals course, and this is the perfect place to start. On its own, this course goes for $129 and is perfect for those that are new to the game or anyone looking to brush up on the core skills of fabrication. In this course, you learn the fundamentals behind motorsport fabrication, more than enough to give you a solid understanding of the materials, tools, techniques, and practical skills that you'll need to perform a huge variety of fabrication tasks with. You'll learn about the pros and cons of different materials we use on the job, as well as how to decide which is the correct material for a particular task. We also go deep into the techniques for cutting, shaping, notching, bending, and welding materials, and how to decide what tools are required for each task. So let's take a look at the other courses we're currently offering. While our fundamentals course does touch on welding, our separate TIG and MIG welding courses go deep into both of these art forms, taking you through each welding method in great detail. These are the perfect courses to look into, and once you've mastered the fundamentals, they're specifically designed to take your welding from a disaster that your mates might laugh about to something that you'd see coming out of a high-end professional shop. Learn all you need to about materials, preparation, welder types and settings, as well as all the correct methods for piecing it all together and ending the day with perfect stack of dime welds and a brand new part made with your own two hands. These courses also feature my own 6-step process that you can follow bit by bit with your own project, which we've found to be incredibly useful in ensuring our students don't miss anything along the way. We also have a range of useful worked examples, with more being added all the time. In these, you can follow me along as I get stuck into a project from planning through to completion, breaking down my process each step of the way. Both the TIG and MIG welding courses are completely separate and go in very deep, specifically catering to each welding method. Now, these usually go for $199 each. Welding and fabrication is no small set of skills, and no doubt you're going to have questions that'll crop up once you get stuck into creating your own parts. We want your projects to take shape successfully as much as you do, which is why we're also including 48 months of access to our private members-only community. This is our gold membership, and on its own, this is valued at $912. That online membership gives you access to our private members-only forum, and this is the best place to get fast, reliable answers to your specific fabrication and welding questions. I'm in there daily along with hundreds of other ETS Fab members, and we're all more than happy to get involved and help you out. You're also going to get access to our regular fortnightly member webinars, which we're just about to kick off and are a little bit like what you're watching now. Every 2 weeks, we choose a particular topic and dive in deep for around an hour. If you're watching live, you can ask questions and get answers in real time. If you can't though, that's fine. All of our webinars get added to our archive after they air, so you can watch them at any time. So that total package has a value of $1,439. For the next 3 days only, we're making this available for just $397. So this presents amazing value for money, and if you're interested in learning how to fabricate within the motorsport world, we know that this is the most cost and time-effective way to do it. We're also aware that $397 is a fair chunk of cash to drop in one go, and we want to try and make this as affordable as we can in order to help as many enthusiasts as possible, which is why we also give you the option of using our payment plan. If you use the plan, you can break that payment of $397 down into as many as 8 individual weekly payments, which will bring it down to a little over $49 a week. Of course, if you do use our payment plan, you don't need to wait 8 weeks before you start learning. You'll get instant access to all of the course material as soon as your first payment has been processed. We're also aware that purchasing online education can be a little bit daunting. If you've never tried learning like this, you don't quite know what you're getting yourself in for, and you might be worried about committing. We want you to be able to purchase with complete confidence and zero risk, which is why we also offer a 60-day, no questions asked money-back guarantee. So if you purchase this package deal or any of our individual courses for that matter, and for any reason at all decide it's not right for you, just let us know and we'll give you a full refund of the purchase price. Don't forget that this package deal is only available for the next 72 hours. So if you want to jump in, do it before the time runs out. If you're keen to get involved right now, I'll get the team to throw a link in the comments that you can follow if you want to make your purchase now. Just before we jump into the questions, I want to give you a quick tour so that you know what it's like to be an ETS Fab member, and we'll also take a look at one of our courses so you can see exactly how they work. Okay, let's jump over to our website. I'm already logged in, so I'm going to head across to my dashboard, which takes me through everything I need to know related to my profile, including my courses. If we click on that, we can scroll down and have a look at the TIG welding course. Here you can see the course is laid out with its different sections and modules. Let's click on View Modules here. This module style of learning makes it really easy to navigate the course, allowing you to quickly find what you're looking for, and it's especially useful if you need to refresh on a certain aspect of TIG welding and want to quickly jump back into that particular module for another look. One of the most important things to learn if you want to master TIG is welding technique, and here we have a specific module that covers everything you need to get it right. Getting your technique right takes time, but with this module you can learn how to master your movements, how to properly control your torch and filler rod, and how to troubleshoot problems with your weld that might be a result of poor technique. Then, once you've got a good handle on technique, as well as a good understanding of all the settings on the welder and how to tailor them for each job, you could check out our material specific section here, which dives into what you need to know and do differently for each material you're dealing with. After that, when you're ready to break out the torch, I always recommend that students spend time following along with me in the 6-step process section. This is where I slowly and methodically go through each and every step of the TIG welding process, explaining it all along the way. This allows you to carry out each step on your own workpiece as I do, which is great for solidifying the entire method in your head and ensuring nothing is missed and no corners are cut. The end result, which is what we're all interested in of course, is going to be an Instagram-worthy stack of dimes TIG weld. It's also worth mentioning that all our courses have plenty of worked examples attached, with more being added all the time. These are great for seeing the entire process in action on a particular job, and if you also need to fabricate a welding bench, like you see here, for example, you can download the plans and make yours alongside me. The idea with these is that all our courses continue to grow and provide value over time. And because you own it for life, it's always there for you to check back in at any time. So just before we check out the questions that I have coming through, I want to show you our community forums. Here you can see that we've got areas for general discussion as well as areas specific to our individual courses. This is the best place to get fast, reliable answers to your specific questions, as well as connect with other students to share ideas and knowledge. Once you've completed the course, you can also request a certificate, which comes through in PDF form. This is a great little addition to your resume if you're looking to jump into fabrication and welding professionally. Or you can just put it on the wall of your workshop to flex on friends. Okay, it's time to answer some of these questions, but remember $397 if you want to buy that package deal in one lump sum. Otherwise, use your payment plan and that'll break it down into 8 weekly payments of just over $49 a week. This price is available for the next 72 hours and includes all of our courses and 2 years of gold level membership. And there's a 60-day money back guarantee. I'll get the team to drop another link to the deal in the comments now. All right, let's jump to the questions. So it looks like we've got a few rolling in here. Thank you again, everyone, for being involved. All right, so we have a couple here. Simon Cullen. Is HF TIG recommended or is it a luxury? Lots of cheap welders are lift start only. Simon, this is a really, really good question, and I see it quite often, and you'll see it all the time with multi-process machines. So that involves maybe a MIG welder also having the ability to TIG weld, which a lot of them do. Now, the problem with this is they won't be high frequency start, which means that they'll be a scratch or a lift start TIG. So what that entails is without high frequency start, you will have to touch the tungsten onto the workpiece to start the arc. Nearly all of these machines will not be compatible with alloy welding either, so you're really limited in the amount of jobs that you can do. One of the problems with scratch start, especially with TIG welding, is that you're basically contaminating the tungsten as soon as you start welding. Now, this might not be a huge issue for mild steel welding, but for any other materials such as titanium, which you can do with a scratch start TIG, but it's not recommended, or stainless, you will create some impurities into the weld, and it won't be as good as a high frequency start TIG. So I would recommend, if you're in the market for one, definitely upgrade to the high frequency start TIG, which will allow an arc to jump off of your tungsten onto the job without contaminating it. So another great thing with high frequency TIGs is they'll usually have other options as well, such as pre and post flow of gas, which your HF or your non-HF or your scratch start TIG will probably not have. So motorsports really pushes the boundaries on our machinery, and we really want the best tools that we can, but you don't have to spend a whole lot. My machine, like I said before, would be around $1,200 US, and it basically does everything that I need it to do, and it's capable of doing everything related to motorsport fabrication. So we have another question here. We have another. Ethan Quirk had the same question. Do you recommend HF TIG? Answered. Easy done. Thanks, Ethan. So we have one here from Quinton. So why does the NHRA require TIG over MIG welding on cages in drag cars to certify chromoly? So this is a really good one, and it goes back to our material elements. So earlier on in this webinar, I spoke about mild steel having a very low carbon content. And what that does is it maintains the malleability of the material. So the heat affected zone, which you can see by the discoloring around the weld, will usually be the weakest point. Now in mild steel, because it doesn't have a whole lot of carbon or other elements such as chromium or molybdenum, it doesn't harden around this area, which is fine. You can MIG weld it, which means a more aggressive input of heat. But when you TIG weld something, you create less heat, and that's why for chromoly, you must not MIG weld chromoly, because this fast input of heat shocks the heat affected zone around the weld and can cause it to become brittle. And on a lot of drag cars, you see them flexing a lot on the start line. And if they're involved in an accident or something of that nature, hitting another car, then what they can do, if their heat affected zone is brittle, they can snap in half, causing a really sharp, jagged break. And it has been known in rally for these breaks to be able to pierce through someone and cause some serious injury. So TIG only on chromoly because it has those extra elements, but with mild steel you can arc weld it or MIG weld it and it won't really cause an issue. So we'll leave a couple till the end, but there's a few in there. David Schultz says, what is the bevel box thing used for? I'm glad you asked because I kind of skipped over that a little. So this is a bevel box, and I'll put it up here. So what this does is it's magnetic, and it will tell you the degree, and you're able to zero the degree. So you can sit this up on any angle and it will give you a digital readout to allow you to understand the angle in which you're bending. And a lot of the time I'll put my tube into the tube bender, I'll take up the pressure, I'll zero this so that I know that that's my straight tube starting point, and then I'll start bending. And this will tell me exactly when I get to the point of bending. And it's similar to a tool like this, but this is really, I guess, not as accurate as the magnetic bevel box. So they're a really handy little tool, and again, quite cheap. And it's these things that in motorsport really help you out when you have extra tools to be able to work with. So let's grab another. Andrew D asks, for novice fabricators, what are some tips for learning TIG? Well, this is a really good question, and this is something that I struggled with when I first started building my Hilux. I had never picked up a TIG welder before. I'd bought a machine. It was less than, I guess, $700 US. It was quite a cheap machine, but it had a whole lot of settings on it that I didn't understand. Now, if my TIG welding course was available in those days, I would have jumped on it, and I would have probably fast-tracked the last 10 years of development that I've had with a TIG welder. But there's a few tips to learn to TIG weld. If you have the option to buy a foot pedal initially when purchasing your machine, it opens up a lot of opportunity to hold the torch in different ways without having the button on it. So this also gives you a lot of options in the fact that you don't have to key in your exact amount of amperage. But a good, if you don't have a foot pedal, then a good rule is 40 amps per millimeter of material thickness. So if you're welding something that's 2 mil thick, then 80 amps will probably be ample for that. Always keep a nice sharp tungsten. Always keep your stick out in the vicinity of the gas flow area. Always keep your flow rate at around 10 to 15 litres per minute, or that's a little under 30 cubic feet per hour. And just make sure that the material that you're welding is ultra clean. I can't stress this enough. In TIG welding, the difference really is in the preparation of the material. Obviously, our weld seam isn't going to be as large as a MIG welder, so we can't weld up the gaps like we would with a MIG welder. So just make sure that all of your material is clean. If you use wax when cutting and then acetone to clean off any residual on the material pre-welding, then you'll have a much greater chance at producing a better weld. And probably the one thing is practice makes perfect. So my Hilux was my first TIG welding job. I'm not proud of some of the welds on it. I mean, I probably did the best ones underneath, which were the last ones that I did, but it's strong, it's held together, and it taught me a lot about TIG welding. So practice makes perfect, and just get into it, and obviously get your practice down. So it looks like we've only got time for a couple more questions, and sorry to those that didn't have their questions answered this time around. We appreciate you all for coming along. We will throw a couple more in the mix. Daryl Lewis says, where do you buy your notch bits from? If you're referring to the hole saws, which I guess could be notch bits, these are, again, a Lennox brand, and I've found that the bimetal makeup of these lasts a lot longer than those that you would buy from, I guess, your home handyman store. These are quite aggressive though, and I've found that the ones that I showed you before, the bimetal cobalt high-speed steel fine-tooth hole saws achieve a much cleaner cut. These were available from my local Motorsport fabricator outlet, where I buy my dies from, and they're really handy for creating nice clean cuts. But just steer away from anything that's too cheap, because you'll probably be having to go back to the store and buy even more when they break. Ethan Quirk says, what HF TIG machine do you recommend, amps, etc.? So Ethan, like we said before, a high frequency TIG, which is basically any dedicated TIG machine, will work for motorsports. What you want to get, and this is something that I didn't think was important when I first started fabricating, was you want to get an AC/DC TIG welder, because it will allow you to work with aluminium. Even if you're not confident with aluminium, you have the ability to try it out. And this is one great thing about TIG welding, because it uses 100% argon gas, which gives you the ability to weld mild steel, stainless steel, titanium, also aluminium, and probably a lot of other metals, including silver and gold, if you want to weld those together. So what amps do I recommend? For motorsports, we really rarely ever work with anything over 6 mil thick. Really, I guess in roll cage construction and chassis construction, we rarely work with anything over 3 millimeters thick. So as I mentioned before, 40 amps per millimeter or 40 amps per thousandths of an inch will give you 120 amps to be able to weld 3 mil. So my welder is a 200 amp machine, and I find it ample for welding in motorsports. As soon as you start to go over 200 amps, then the torch will get extremely hot, and you'll probably have to upgrade to a water-cooled torch. These actually get larger in size and are less or more designed for industrial applications rather than motorsport. So if you've got a TIG that's an AC/DC, has the capability to weld 200 amps, can still plug into your wall socket at home. That's another thing to note. You have to buy, and we mentioned this in the TIG course, you have to buy what you can power. So if you haven't got a 15 amp circuit, or you haven't got a 3-phase circuit, then you'll need a machine that suits your workshop, and you can input a 15 amp circuit into any workshop, or you can get an adapter that plugs into it. So 200 amps AC/DC welder will do the job. All right, that about finishes up, and a big thank you to everyone who joined us today for this webinar. I hope you've enjoyed it and learnt something along the way. Remember, if you think taking your skills to the next level through our courses might be for you, our $397 package deal will be valid for the next 3 days. It includes all our courses and a 2-year gold membership to ETS Fab, and has a 60-day money-back guarantee. If it's not for you, don't stress. You can just let us know and we'll refund your money. Jono has just dropped the link in the deal into the chat. And again, if you want to take a closer look, then click on that and it'll give you all the information. All right, let's just grab another question, shall we? I don't know whether we're over time, but we'll give it a go. We have one from Jacob Witten. What type of drill bits stay sharp the longest? High-speed steel, titanium, etc. Really good question, and one before we finish up. This is a high-speed steel drill bit. I don't have an issue with these. Again, as long as you use coolant, then they're relatively cheap to purchase. They're easy to sharpen on a bench grinder, and again, using coolant and the right speed on your drill. Remember, the larger the drill, the slower you go, then they should last a long time. So I think that's about it. All right, thanks again for joining us, guys, and I hope to see everyone online again soon.